Alright, so now that we know all about what a GCF is and how to find it, we can take that greatest common factor and factor it out of expressions. And this is going to help us get to the point where we were with the Frogs and the Fleas book where we factored trinomials. But before we can remember about that, we need to factor different things. So what we're going to do for all of these examples, A, B, C, D, E, is figure out what they have in common and then take it out of each one of those terms, or factor it out of those terms. So think back to the distributive property. It said if you had a number, you could multiply that number by both things inside of the parenthesis, and you'd end up with A times B plus A times C. This also works backwards. So if you notice, both of those things, A, B, and AC, have an A in common. So we can take that out, or divide both things by A. When we do that, we end up with A on the outside, and then times B plus C. So in order to do any factoring like this, we first need to figure out what the greatest common factor is, and then go through and divide each of our terms by that. So for A, those terms, 2x squared and negative 4, both have a 2 in common. That's our GCF. So I'm going to take my GCF of 2, and I'm going to factor it out of that. So if I have 2 on the outside, I'm undoing distribution. So if you divide 2 by 2x squared, all you're left with is x squared. And then do the same thing with 4, and you end up with negative 2. And this is something that you can always check. If you distribute 2 back into here, what do you get? 2x squared. And on this one, you get negative 4. So this is our answer right here. That's the factored form of what we started with. Let's try B. First, you got to figure out what the GCF is. So in this case, I noticed they both have a negative. That's something I want to take out. So negative something. They both have a 4 in common. And then the other thing that they have in common is they both have at least one x. So that's what I'm going to take out, negative 4x. So once I pull out negative 4x, see what we have left. So negative 20 divided by negative 4 will give me 5. And then I divided the x, so I don't need another one of them. And then do the same thing with this negative 16. So negative 16 divided by negative 4 will give me positive 4. And I only took away one x, so we get 4x. Another way to look at this besides just doing division is to kind of see if I take away 4x, what would I need to multiply for negative 4x by to give me negative 20x? So all I'd have to multiply is 5. What would I need to multiply negative 4x by to end up with negative 16x squared? Well, we'd have to multiply by 4 to get the 16 part, and then one more x to get x squared. So try the next 3 on your own. Go ahead and pause the video, and I'll throw the answers up there. Alright, here are your answers. The first one you should have taken out as 6x, and you were left with 3x squared minus 1x minus 2. You don't really need that 1 there, but if you put it on there, it's not wrong. D is not factorable. The only thing those things have in common is a 1, and it doesn't make much sense to take a 1 out because you're not going to change anything. E, you could take out an x from both of them, and I know it's always very tempting to take out an x and say, well, these cross off, so I don't need them anymore. But remember, you should be able to distribute this back in. So if you just had 14x, you distribute it to that, and all you're left with is the 14x squared. You want to be able to multiply this x by 1 so that you end up with this plus x that you had in the original equation. Alright, so sometimes a binomial factor is in an expression. We can still factor that out. That's still something in common. Remember back when we defined terms, we said that it was a group of things multiplied together. So in this case right here, 5 times x plus 2, this is 2 things, the 5, and the x plus 2 multiplied together. That's one term. And then this stuff over here, 3x times x plus 2, is one more term. So you ask yourself, what do those 2 terms have in common? And they both have an x plus 2. So that is my GCF And that's what I can factor out of both of these. So I'm going to factor out an x plus 2. And then just like before, you have to ask yourself, if I took out an x plus 2 from this term right here, or you can think about dividing it, what would I have left? I would just have a 5 left there. And then do the same thing here. If I took out an x plus 2, what would I have left? Well, I would just have positive 3x's left. So this right here, x plus 2 times 5 plus 3x, is the same thing, but just factored of the one that I started with. The next one, we can do kind of the same thing. We have these two terms here. We have this red term, and then we have this green term. They both have that 3 minus x in common. That's our greatest common factor, and that's what we're going to want to pull out, or to factor out. And then we can ask ourselves, well, if I took away 3 minus x, what would I have to do to get t times 3 minus x? Well, all that we would need is the t. And same thing here. You can think about what would I need to multiply 3 minus x by to give me this, or you could divide it by what we factored out. Either way, you'll end up with negative 5 being the only thing you need. Go ahead and try the other two and pause the video. Alright, so the first one that you should have done on your own, you should have taken out 4 plus x, and then what's left is the 5rs from this term, and then the 3 from that term. And then the last one is not factorable. They don't have anything in common. Remember, these are your two terms. So this one has a 3 and an x. The next one doesn't. This one has a 4 plus y, and the other one has a c minus 4. There's nothing in common, so there's nothing we can take out, just like this problem right here. Alright, so sometimes we need to use the distributive property twice to completely factor. So sometimes we need to do what we just did 2 different times. Whenever you are given something with 4 terms, we want to do something called factoring by grouping. That should sound familiar from the stuff that we did in the last book. But what it means is break things up into basically 2 sections. So forget about this stuff right here for the moment, and let's just worry about this stuff here. What's the greatest common factor of 12AC plus 21AD? Well, just my numbers, I have a 3 in common. And then my letters, they both have an A that I can take out. And then what I would have left, 3 times 4 is going to give me that 12. I already have an A there, so I need a C. And the same thing with 21. 3 times 7 will give me the 21. I already have the A part, so I need the D. And once we've concerned ourselves with that section that we have, forget that that's there, and let's just look at this section right here. What do those 2 things have in common? Well, number-wise, they both have a 2 that I can take out, and then they both have a B that I can take out. And then figure out what's left. I have 4 in C, and then in this next one, I'd have to multiply 2 times 7, and then I'd need a D. And once we get this far, we realize that it looks just like these problems that we did here. These 2 terms, now the green term and the blue term, have something in common that I can factor out. They both have a 4C plus 7D. And then if I take that part out of this green part, all I have left is 3A, so that has to go in my other term. And out of the blue part, I have plus 2B. So now I know it's totally factored. They don't have anything else in common. Go ahead and pause the video and try this next one. So your final answer for this should have been 3h minus 2 times 2h to the 3rd power plus 4. So out of the red grouping here, I could pull out a 2h cubed. Now the blue group here, I could pull out a 4, and that left me with like terms again. The 3h minus 2 on both of them, which I could then factor out. All right, last type of problem we're going to do is opposite expressions. So let's look at this first one. I have 5 times t minus 2 plus 6 times 2 minus t. Now hopefully you notice that these look very close to being the same thing, but they're not exact. So I have t minus 2 and then 2 minus t. This is the way that we tend to write things, t minus 2, the variable first. So let's switch this one around so it's the variable first. This says that I have negative t plus 2. Again, really close to the other one, but not exact. So when you get something like this that's really close, what we can do is we can factor out a negative. So right here, if I take out a negative 1, I end up with just t, and then take a negative 1 out of positive 2, I end up with negative 2. Double check that that factors back in. You have negative t plus 2, which is what I have up here. But now the stuff in parentheses looks exactly the same. This and this. So it's really, these opposite terms is really whatever you have in parentheses multiplied by negative 1. It's kind of in disguise. So I could rewrite this part right here as 6 times the negative 1 that I took out times t minus 2. Or multiply that together, we get negative 6 times t minus 2. Same exact expression, I just worked things around. And then we still have this part right here, 5 times t minus 2. And now this looks like the problems we just got done doing. We can easily see that both of these have a t minus 2 in them. And we factor that out, we're left with 5 minus 6. And then don't leave it like this. 5 minus 6 is definitely something we can simplify. We'll end up with t minus 2 times negative 1, or you could write it as negative 1 times t minus 2. Alright, the last problem, try on your own. You got to go from start to finish, and you might have to do this opposite expression thing. Pause the video, and I'll have the answers up when you hit play. Alright, so this box in black is what you should have gotten. So first you had to do some factoring by grouping and group up those two. You could pull out a 3x and you're left with 5 minus y. And then you can group up the 4y and the negative 20. Once you did that, you should have noticed that you had those opposite terms again. So I took this part right here and took out a negative 1, just like we did back up here. And once I did that, realized that that switched the signs. This made the negative y positive and the positive 5 negative. And because of that, I ended up with the same terms there. And that's what I could factor out, and I'm left with negative 3x plus 4. And we're done.